So good afternoon to all of the honorable judges. I'm Gan Shovin from Team Lumina from Malaysia. So now, actually our team consists of 5 members. Next one, my team lead, I'm the programmer, Restan the artist, Karbun our UI UX artist, and Jenna our project manager. And we also participate in Malaysia Grand Week event and SCMC Graph. And we are very happy to be Taiwan in APICTA Awards. So, what is Lumina? Lumina is actually a top-down team-based PvP arena where rivals crew are mined rails and outplay each other by utilizing strategy and visibility. So actually it's a PvP game, but we want to make it more than a game. What's the reason? I will tell you later. So this is our core gameplay. It's actually pretty easy. We go and find and mine and collect the ores. We go in the middle and deposit the Tertiary, and we can sabotage the enemies by to distract them to go into the middle to the objectives. And actually we designed 2 types of spaceships. One is assassin, which have a low fire rate, but the damage is very high, and it has an ability which it can hide in the shadow, which is marked in the darkness, and if you do not consume the field. And for defender, it acts as a tank, and it has a higher fire rate and higher health rate, and it is help to support and heal the players around itself, but the damage is lower. And so the gameplay loop already formed, which is you start the game, you go to find the ores and mine, and you collect it, go in the middle to deposit the ores to the Tertiary. And the objective is, if this bar reach 100, you win the game, or the timer ends, the game will stop. So, but just now I said, we don't want Lumina to be just a game. We want it to be a technical playground to test cutting the edge technology to their limits. So we want to push our technology to the limits by lessening the computational cost and optimizing our games. How? So we create a bunch of libraries of tools to make this game. So we create a dynamic vector graphic framework and radiance cascade, a global illumination method, and motion GFX. We also use berry types, Radar, Rust, and some online multiplayer technology as our game. So let me introduce the comprehensive suite behind the technology. And yeah, types. Why we choose types? Types is actually a markup language similar to LaTeX, but it has a more simple syntax and is very faster. And the reason behind it, because it can do visualizations, some algorithm and mathematics automatically, and bibliography, and even do slides. And that's why our team create this library called Valis. So why we create Valis? Because we want to have the logic to hot reload. Normally, when we change the color, we change the, like I said, the CSS behind it, the UI. So we need to do a lot of compilation, but with hot reload, we can live preview it. So how we can add a condition into this technology, like we add for example, if this is greater than 5, this is size, then we change it. Yeah, this is about logic hot reload, and we can bring the value from our codes inside types straight away. So for example, the health value, what we want to do with this health value? For example, we change the color. Maybe the when it have a lower health, then we want to have a pulse icon. We segment the health bar. This is all can be done by this our UI framework, where this and also a real-time vector graphics. Because this is the designer always face some issues, obstacles, like when you scale the image, it will be pixelated. But with a vector graphic UI animation library, it will not happen this issue, because first it will have no pixelation effects, because it's all vector graphics, it's by mathematics. So when you scale up 100 times, 1000 times, it will also as clear as before, and you also support SVG specs like gradients, curve. So we are, imagine you're having a real-time Adobe Illustrator but in code programming. That's why we developed this to the programmers. And this is the output. So when you hover the selection, you can see it become bigger. Our UI, the main menu, also done by Redis, and also the health bar, the abilities, and so on. And next, we also create this library called MotionGFS, which is a backend agnostic procedural library. Why backend agnostic? Because it can run in any backend, and procedurals mean programming for functions, loops, it can be included. Now I will play a short video to explain a bit about this.
Usually objects are animated in a declarative way. We say at frame 10 this circle should be here, at frame 30 this should be there, and so on. The animation software then interpolates between these keyframes, producing movement. You might have seen it in After Effects, Blender, Unity, but when using code, we can start thinking about animation as a series of commands. We say do nothing for 10 frames, then move the circle to the right in a span of 20 frames, and so on. This is a more imperative approach that closely mimics how code is written. And when an event happens, you need to manually readjust all the following keyframes. But with commands, you only need to edit this one duration, and the rest will follow. Another benefit is that we can use programming concepts to control the animation. We can use loops to create repetition, write functions for reusing common FX, or use external data to procedurally generate objects.
So MotionGFS allows the developers have more control on the animation without manually set the keyframes. So because we want to the designer have the freedom of just doing the design, no need to worry about this. So we can also use the programming method, the for loops, the functions to help the programmers to straight away use programming method to code the animations. So yeah, like I said, it can be real time. It got ECS support, which is data driven. We do want to make it just for game dev, but we also want to include software and two-way playback, which you can play it in front and play back but it don't have an animation library like others because we want it to be more customization. Maybe in future we will create more templates for the animation. And this is an example we use Redis and MotionGFS to animate the types documentation. And next, we also implement a radiance cascade, which is a global illumination method. So we introduce this negative lighting because normally in the mainstream game engine like Unity, Unreal, it don't have a negative lighting, which they assume the radiance always bigger than 0. So with negative lighting, with less than 0, we can help it absorb the light from others, like you see, which this is one of the ability of our game. And next, for the transparency, it can free transparency out of the box. You can, for example, a shining white light through a green filter will reveal a green light on the other end. So in this, if you do with ray tracing, it will be heavy computational cost. But with radiance cascade, because the global field only compute once, so it will be far lesser than a normal ray tracing, which can help the normal laptop also can run this game. And it can also have free form of shapes because it's mathematics, so you can as many shapes you want with the same runtime cost. For example, you see the lights here, yeah, you can see it. So we want to hit this technical limitation. For designer, you just design your thing, but the technical limitation you just bring for us. And this is before we implement radiance cascade, and this is after it. So you can see the difference on it. And also let me talk about the theory behind it. Like you see, the penumbra is the, like when you closer, it will have the higher details. When far away, it will have low details. But why the transition is so smooth? Because it have a penumbra to apply a small transition between it. And let's say, like I said, when it's nearer, have a more lesser direction but more details. But when you outside the props, it will have more direction but lesser details, so it can be more optimized in our solution. And this is some screenshot of our game. You can see the UI by where it is. And also, yeah.
Okay, time is up.